Artificial intelligence has changed the server industry over the last few years. Between that development and advances in machine learning, our embedded space is changing as well, with capabilities like voice recognition, object detection, and smart sensing becoming product requirements. With AI evolving into a wide range of applications at an incredible speed, engineers are in strong need of new performance and low-power processors and easy-to-use associated evaluation platforms that can bring their ideas to the market faster. With the growing adoption of different AI models really dominating the server space, it feels a little bit like the GPU has kind of stolen all the headlines in the technology industry over the course of the last couple of years. For us in the embedded electrical space, the CPU is still king, and we're required really to make the CPU sing in new ways that we never have had to before as that AI and machine learning comes down onto the edge into our applications. And beyond that, we've got to figure out ways to take those CPUs, get higher levels of performance out of them for lower costs, lower power consumption, and sometimes that entire thing can be quite daunting. Today I've got the absolute privilege of speaking with Daniel Howe, who is the technical marketing engineer at NXP, in charge of a lot of the families that they're working on and their processors and microcontrollers. Daniel, thanks so much for joining me yet again on The Current today.
Hi, Todd. Yeah, so happy to be back with you. I'm excited to talk about this topic before.
Yeah, it's really an important topic, and I think, like I said, I think we hear a lot about what NVIDIA is doing with their GPUs, and that's really exciting. That's what all the headlines are about these days. But there still is a lot of great innovation going on, more in our embedded space when it comes to processors and microprocessors. So, what are some of the most significant areas and applications that you're seeing grow rapidly that are requiring the need for better embedded processors?
Definitely, yeah. So I'm seeing a lot of actually needs in different market and applications that needs that processing capability and processors, right? As you mentioned, definitely GPU has kind of taken the headline for when it comes to AI at the edge. But relatively speaking, that there are a lot of engineers out there who's more familiar with the CPU development environment, and frankly speaking, I'm seeing a lot of growth in certain area, and I'm seeing basically like a cross versus a vertical segments, several vertical segments that has high growth, and also some more of a horizontal technologies that has high growth at the same time. So speaking of vertical segments, right, you're talking about firstly factory automation that needs a lot of real-time applications where the processor really shines, that needs a lot of data throughput with networking to control the process. So that's where a lot of CPUs shines in there. Yeah. You're also talking about home control or building control, right? From little things like your control panel for your smart home, all the way to like a control panel to a building, and it needs a lot of processing through different data coming from your thermostat, coming from your lighting control, coming from your voice command, and all those add up and needs a central processing unit to be the manager of that whole system.
Yeah.
And then we're talking about also healthcare space. We're seeing more and more either vision or audio processing, or even like machine learning in the healthcare space a lot, and also a lot of advancement in graphical HMI, human-machine interface. Right. We also are seeing a lot of advancement in power and energy space, right, where you see the evolvement in terms of energy storage. I know we're talking about more lower level versus higher level system, where lower level you're doing the battery management. Right. That's more of your microcontroller, your analog, right? But on a higher level, you need again a system manager to securely allocate all the resources, to deal with all the heavy data, and with all the new standards of energy storage coming into the market, right? It needs a better platform than a simple microcontroller to deal with all those kind of standards. Yeah. So that's vertical. And horizontal, across all the segments, you're seeing advancement and needs in terms of graphical. We're seeing more and more advancement in terms of graphic display, HMI, voice and vision, right? And then also that ties into your AI and machine learning advancement, where voice recognition and machine vision comes into play.
Right, no doubt. And I think with all those things becoming so much more important in the designs that we're working on, the design exercise becomes much more of a software exercise than a hardware exercise. And I know what I've certainly seen is that, back in my design days, as the hardware engineer, I selected the microprocessor, the microcontroller we were going with, and had really kind of, this is what we're going to do. What I've seen really change, I think, in the last couple of years, and maybe even longer, is that the software engineer is the one that's really saying, no, I need something that's got an MMU. I need to be able to have Linux on this. The majority of the design challenge is going to be really happening on the software side, so you've got to select a processor for me that's going to allow me to put a Linux kernel on it, be able to run a bunch of different threads and make all that happen. So I think there's been an enormous change there, no matter what kind of application we're talking about.
So. Yeah, exactly. That makes you and me both. I started off as a hardware engineer too.
Yeah. So I mean, it's changed. Our dear friends at the software side have gotten a lot more power, I think, in selecting how the hardware is going to go. And good for them. I think it does make our designs better. And again, the goal is, how do we really expedite the time to market with any of the designs that we're looking at? Now, what I find with that sometimes, though, is that again, we're looking at ease of the software side, and how do we make that software easier to develop with, and to take the operating system, develop the application code, and get running a little bit faster. But sometimes when you're then going to a processor and you've got to have an MMU on board, it does sometimes feel like, wow, that's a lot of horsepower for that application, and maybe even a little bit of overkill, I think, sometimes when we're looking at that. So we're really thinking from a software standpoint, but what are the key hardware considerations for engineers to consider when they're selecting these embedded processors today?
That's a very good point, Todd. For me, knowing software engineers usually think they have unlimited resources when they develop their applications, right? But in the reality is that, especially when you get closer to the edge, you need to be considerable for those hardware limitation, or really to choose the right hardware for you.
Right.
So I think number one is still the processing capability. Do you really need that much of horsepower to do the tasks? Sometimes do you need a dual core in the processor to do it, or you can get away with a single core. Mm-hmm. But there's other things that's added to it. For example, like nowadays processors, if you're talking about like the i.MX processors, they all have different accelerators, peripherals, and co-processors. For example, like neural processing unit that we integrated onto the device to do machine learning. So I think it's past beyond the time where you just look at how fast the CPU is. You need to look at all the other things around the CPU that's built for a certain use case. And for that use case, you might get that right processing capability with the lowest processing speed that you can offer, right? So this is something that's integration. Another thing I would say is low power. So you're dealing with devices at the edge. A lot of them are based on battery or has a certain limitation in terms of energy consumption. So you need to think about how to utilize. Nowadays, the processors has heterogeneous architecture where you have Cortex-A core versus also having a Cortex-M core that's real-time core to run some RTOS. So you could have different power domains in your device to build your power profile to optimize that power consumption of your device. And also that leads into heat dissipation. That's also a hardware consideration here. So there are some newer technology, for example, on i.MX that we apply, things like the non-lit package options, which needs a little bit of care in terms of hardware design, but it gets you a lot in terms of heat dissipation advancement. So that's something also that's I think it's worth considering.
Right.
There's also, things around the device like, your memory access, like LPDDR. We have generations and generations of DDR coming out, and they all have their benefits, and they all have their low power aspect to it.
Right, right. And I think one of the things I like about the Item X family, not to turn this into a commercial for NXP, but I think it is a great family, and we've been using it for a lot of years. But the fact that you can go from single core to quad core, and there's a lot of area to move up and down the chain depending on the exactly what your application needs, pretty easily. So you can go from one design and one product that maybe doesn't need all that much functionality and is good with one core, and then pretty easy on your next generation migrate, hey, I need to do a lot more with this next generation, so I need to move to the quad core. It's a pretty easy evolution, I think, with the way that you guys have built things. And so that I think is raised some challenges in itself as well. And that, again, I've been working with Item X's, I think, for 15 years or so. I remember working with the Item X 23s and 27s, and the 3 series, the 5 series. The 5 series quickly became the 6 series, and then the 6 series now is the 8. Really is kind of taking its place, and now we've got the brand new one, the 9 series of Item X. That's really, really exciting. And I think the 8 and the 9 are kind of where NXP is steering most customers to these days. So what are the considerations that engineers should be thinking about, whether we're going to decide on an Item X8, which could be single core up to quad core, or an Item X9? When do you make that transition from one family member to the other?
Absolutely. I mean, we've gone a long way here today. Item X6 is one of the most popular application processing in its own category. We have a lot of people who are still a fan of the Item X6. We just extended the longevity program for that to, I think, 2035. Yeah. So, if you are happy with your Item X6, just keep using it, I would say. But in terms of, you have a very good point in terms of selecting versus Item X8, which is a more mature portfolio that we have today versus Item X9. I think, so we just launched the Item X93 and soon to be 91. Right. So this new series is really in its kind of like prospering phase where the Item X93 right now goes up to 2 cores. We announced the Item X95 and 94 that would go to more cores and more processing capability. But at the same time, the Item X8, you have the Item X8M Plus, that's like the bigger brother to the whole portfolio. That's quad core, super powerful. It has a new processing unit in there. I know Future built a board off of it.
Yeah. Or Goldilocks
very,
platform.
Very amazing job.
Yeah, absolutely.
Yep. Yeah. Very good platform. So I would say it's really, firstly, by use case. If you need that, advancement in terms of Cortex A55, which is on the 9 versus A53 is on the 8. Right. You do get a lot of benefits out of it. Another thing I would say is security, where the whole security requirements has been evolving so quickly nowadays. Before you know this, you're talking about like quantum computing attack already. So for example, for the new Item X9, we all have this edge-lock secure enclave, which is kind of like a standalone subsystem to make sure your SoC is secured. And we also have things like the PQC, which is designed for preventing from the quantum computing attack. Right. So all these newest technology in terms of security is on the line 9 versus 8. Definitely a secure device, but not the newest in terms of security offering. But I would say, based on your requirement or use case of the horsepower you need, the features you need, you can choose in between those two, and it's pretty scalable and easy to move back and forth with these two series with our software enablement.
Right. And I think software enablement's critical. I think the hardware enablement is important as well because again, having used the
Exactly.
i.MX family for 15 years, typically eval platforms, reference designs that I've used and that I've taken into other engineers and helped them to use, they've been pretty large. They've been pretty expensive. A lot of times thousands of dollars, sometimes for the reference design or the board that an engineer is going to use to bring up their proof of concept. And you're like, I'm going to eventually put this thing into a little box that's 4 inches by 5 inches, and I'm having to do it on an eval board the size of my desk. What are some of the things that NXP is doing to make that a little bit easier for engineers when they're doing a design on a processor platform, to make that a little bit simpler, to enable them to quickly get a proof of concept up and going?
Definitely. That's a great question, Todd. I would say, Future did a pretty good job with the Goldilocks
We're proud of it,
board
yeah.
on the item-X.
And for that one,
Plus.
that's one that we essentially looked at, some other devices out in the market, like the Raspberry Pi, which I think is a phenomenal little platform.
Exactly.
Great form factor, but can be a chance. Some customers have even tried to productize that, and it can sometimes become a challenge because the longevity is not always there for the same device. So we said, hey, can we take an i.MX 8M Plus, put that in the same form factor, and make the design files for that available to our customers? It's been a real successful thing, and we're really proud of it. I think it's got a lot of legs with it still. Yeah.
Exactly, and we see that the same way. So that's why if you have heard of the Freedom platform,
Yeah.
That we started off from the microcontroller world, and now we are actually moving that towards the i.MX processor world. We just announced the Freedom i.MX 93 board.
Right.
I happen to have one by my desk.
Yeah. Right. Okay.
Look at this board. So I have this box opened with the board. This is how big the board is.
Yeah.
This is very compact, kind of like a Raspberry Pi sort of form factor. We're selling this at $80. So
Wow.
if you are familiar with like a more of a traditional EVK or evaluation kit approach for those processors,
Yeah.
this makes a huge difference in terms of pricing. And you're paying $80 for the board, but what you get out of that $80 is really, if you look at the hardware, you have all the necessary components on there with i.MX 93 on there.
Yeah.
You have Ethernet ports. You have a Wi-Fi module, also supported by NXP's SoC to enable the board to be connected. You have USB and camera interfaces, audio interfaces, HDMI for the for monitor interfaces, and you also have the Raspberry Pi connectors there.
Right. Right.
So it's a pretty compact board for a lot of connectivity on there for your prototyping. That's the hardware you get. On top of that, you also get the software, right? So we have the dedicated BSP for this board with Linux, and we also have what we call the GoPoint demo places. So when you get the board, it's preloaded by an image where you could start off the board, and then there are a lot of demos already that you can run with the board, like machine vision, vision pipeline, camera interfaces, graphical examples on there. I think one of the most frustrated thing for an engineer when they first get a evaluation kit is that they couldn't get the board started running with their first example, right? So this is really, we're trying to get over the hump with the demo place or the goal point. But that's something also added to it that goes beyond software and hardware. And Todd, you just touched on that with the Goldilocks, right? So we have the Raspberry Pi. It's pretty popular in the market. If you ask any makers or students, even startups, they definitely are fans of Raspberry Pis.
No question.
Yeah.
Yeah.
The problem occurs when you are trying to really get serious with your design and really trying to get into the industry, and that's where we see a gap there. Future saw a gap there, and that's why you designed the Goldilocks. This board, we have everything open source. It's an open source platform, open source hardware with open source software. So basically, you're taking a design that's designed by NXP engineers with the NXP processors. That's all professional design, ready for the industry, ready for production.
Right.
And you can take that into your design very easily. And that really speed up your design cycle.
Right.
And also for the students out there, for the makers out there, startups, this is a processor that's widely adopted by the industry. So this really gives you a bridge from the Raspberry Pi world to the serious industrial design with an industrial graded processor.
Right. I think that's incredibly powerful. And so I assume that NXP's plan with that is to make the Gerbers available, the schematics available, and so essentially, if you're doing a design with an Item-X 9 level of embedded processor, the layout alone, just the breakout of that package is pretty complex. And so if you hand that to a hardware engineer, man, 75-80% of your hardware design is probably done at that point. So I think that's really powerful. And then you're able to kind of take that, pick and choose, say, I only need one Ethernet port. Oh, I don't want to use this Wi-Fi module. I want to use something else. I need to add this sensor over here. It expedites designs tremendously, and that's what we saw with the Goldilocks as well, and continue to see is customers taking that design and saying, wow, all I got to do is make a couple tweaks to the Gerbers, a couple tweaks to the schematic, and boom, I can go send this to the board house in a couple of weeks and get the board back and start doing my software and firmware design. And we're accelerating our time to market, sometimes saving months, 6 months of design cycle just through doing that. So I think it's a really powerful thing that the Freedom series is doing, not just for the MPUs, but I've been playing around with the MCX N with a ultra wideband radio on it, and so this is the Freedom board for that. It really makes it easy for engineers because you've got all the Arduino headers, you've got microbus headers, everything else for the click boards. Proof of concept, it's like butter now. The way that works. So I really do think that's a great thing. Outside of just kind of the ecosystem you guys have built for the application boards and bringing that up, what are some of the other ecosystem tools that NXP is making available, maybe more on the software side, maybe on the IDE side, to make that easier for engineers that are maybe doing machine vision or machine learning or implementing AI or implementing security? What kind of tools are available and that you guys are spending some time on for the engineering community?
Yeah, we're indeed spending a lot of time on those tools. I think first and foremost is the foundation of that is the Linux BSP. We make sure we do a quarterly update to the BSP based on the Linux foundation. So we're very up to date in terms of your foundation of your OS. And then secondly, we mentioned about things like heterogeneous processing nowadays, where your processor has a real-time core on there. So we want to make sure it's easy for the user to make use of that real-time core. Right. So we're supporting RTOS, like if you heard of Zephyr, this is going very, very big lately, right?
Yeah.
We're supporting that with the M core. And also, we have something called a real-time edge software that is basically a software enablement to kind of allocate your Cortex-A core, your application core, to work as if it is a real-time core, so that you can actually run things like Zephyr or FreeRTOS on a real-time core. On a application core. So that's something I think is going to be really comes in handy when you're dealing with a lot of real-time processing.
Right.
Things when it comes to machine learning and AI, we have been investing a lot in those spaces. The general tool name is called EIQ Toolkit. That has a lot of things under its umbrella. I can name two of the most the newest updates that we have. Firstly, if you're familiar with time series data analysis or machine learning, this is going bigger and bigger in the industry right now. Right. It's not only about recognizing a face or doing a voice recognition. Of course, those are big, but we're seeing more and more of data mining, more of sensor data analysis to do for example anomaly detection or prevent device to go run unexpectedly. So a lot of those can be done by the time, what we call the time series studio inside the EIQ toolchain.
Okay.
Now we see the most difficult thing for the users who want to apply the time series data analysis is that there isn't really like a one model to use on the market versus if you're doing like a facial recognition, there are certain models out there that you can use it to retrain.
Right.
But now for time series data is pretty new. Everybody has its own customized data set. So that's why we have this time series studio that has some, widely used model, but it's also very flexible. So you could bring your own data set and train your model in the EIQ time series studio.
Okay.
Another thing that we are doing is we're looking into Gen AI. That's another hot word today. We're looking into enabling, for example, large language model into the ILMX. That's going to be our ILMX 95, which is a way more powerful device in terms of AI and ML capability. So at the same time, we're looking into Gen AI, which is more advanced, and time series data analysis, which is also a very emerging technology that's going on.
Yeah. Really exciting stuff, and certainly AI and machine learning are changing our world rapidly. Like I said, they're dominating so many of the headlines right now. But again, I think there's a little bit of an oversight, I think, in the market right now about how much that's going to impact the embedded design space, not just what's going on, in the server farms and in our laptops. It's much bigger than ChatGPT or any of those large language models. I think it's going to be exciting to kind of watch how it continues to matriculate down into our space as well, and what we're going to be able to do to change the world with it. So, very, very
exactly.
Cool. So, Daniel, thanks so much. Always a pleasure to talk to you, my friend. I really appreciate you being on The Current again. Thank you to our audience for joining us as well. I hope this was a useful conversation for you to maybe get a couple ideas going and kind of see some of the direction the market's going. If you have questions on this, how to implement AI and ML into your embedded applications, how to look for a processor, or if you're interested in the new IDMX 93 Freedom platform, we would absolutely love to help you with our engineering team at Future Electronics, make introductions with our good friends at NXP, and help advance your designs. Please reach out to us at Shaping the Future, one word, Shaping the Future, at futureelectronics.com, and we'd be happy to have one of our engineers. We've got engineers all over the world that can meet with you and work with you on your designs. Thank you so much for joining us on this episode of The Current, and we'll look forward to seeing you next time.